Welcome back to the Cave of Science, and we're going to do actually probably about 4 or 5 parts to a test review for Unit 8 in stoichiometry. So I pulled a bunch of problems together very similar to the type you're going to see on the test, and we'll go through these, and it'll be a good review. So the first one here, we've got a multiple choice problem which says which of the following is not conserved in a chemical reaction, and we're given the 4 choices. Always kind of interesting in multiple choice tests. You naturally go to the answer that includes all the above possibilities. But in this one we're going to let's go through it once to make sure that is the correct answer. Well, we know when we balance an equation, so we can throw an equation up here. Let's just do the one for water. Let me throw that up there. And we need to balance that. So we got that balanced. Okay, so which of the following is not conserved in a chemical reaction? The number of atoms? Well, when you balance an equation, you are conserving the number of atoms. The number of molecules. Well, if we look on this one, looks like we got 2 here and 1 here of the oxygen, and we've only got 2 over on the product side. So that is definitely not conserved. And if we were given grams, grams is a unit of mass, and as we know, matter cannot be created nor destroyed. So mass, is going to be conserved in a reaction. So the best answer for this one is the number of molecules. And with number 2, we can go right along with it. The flask diagram above contains hydrogen and oxygen gas. When a spark is touched to the flask, they combine to form water. So we know we're going to get H2O. If the original reaction mixture contained more oxygen gas, the amount of water produced would, and we got to decide it's going to stay the same, increase, decrease, or depends on the amount of oxygen added. Well, notice we are adding more oxygen, not hydrogen. And we need 1 oxygen atom for every 2 hydrogens. So we've got 1, 2, 3, 4, 5 molecules of hydrogen. So we can form 1, 2, 3, 4, 5 molecules of water, and we only need 1 atom of oxygen here. So we really only need 5 oxygens, and we've got 1, 2, 3, 4, 5, 6. So really we've got more oxygen than we can use. So if we throw so if we throw more oxygen into the container, it's really not going to change the amount of water produced, because again, water contains 2 hydrogens. So hydrogen is the limiting reagent here. So if we throw more hydrogen in, more oxygen in there, it's going to stay the same. And the third one, the calculated amount of product that should ideally be produced in a chemical reaction. Well, we've never talked about true yield. Actual yield is what you actually get experimentally. Theoretical really is what you should get. That is the 100%. If the reaction was perfect, went to completion, ideally you'd get the theoretical yield. And we know the percent yield is the actual divided by theoretical. But ideally, you should get the theoretical yield. Alright, so there's the first 3, and we're going to be doing some more here on the next one, so stay tuned.